folks just to log in and tell us where you're from. You go into the chat function, let us know, which agency you're with. And if you're in a conference room with 4 or 5 or 6 or 20 or 50 people, it'd be great to just know. We'd like to keep track of how many people we're able to, share information with. So that would be great. And again, throughout the presentation, and I think John mentioned this, but everybody's muted. It's a big enough group that we have to kind of keep it, I say, under control so that we're not talking over each other. So we're asking you to use the chat function or the Q&A function. John's going to be monitoring that. So if you have a question, post it. If need be, John will interrupt me and I'll try and answer the question right then. Or Jason might be able to answer it just kind of one-on-one through the function. I get focused on the slides, and so I'm not really paying attention to the questions. So I rely on Jason and John, and they'll do a great job of that. So, and then the other thing, just real quick before we get started, and when I'm talking about a subject, and I'm sharing my experience, my 45 years of experience. Yes, I'm old. 45 years of experience, but I'm still learning stuff. So if I am talking about something in your city, your county, your DOT has found a better way to do what I'm talking about, please share that. There's a lot of brain power on this webinar, and so let's take advantage of it. So anyway, that would be great. So I'm going to just jump in here. We got a lot of material to cover. So I know a lot of you know me, but basically I spent about 37 years with the Alaska Department of Transportation and Public Facilities. I actually started on the engineering side of the house, discovered maintenance and operations about 5 or 6 years into my career, made the move over to maintenance and operations. Greatest career decision I ever made. Haven't looked back. And so out of my 44, 45-year career, probably about 40 years of that has been in maintenance and operations. And so I'd like to just share things, my experiences, things I've learned over the years, things I'm still learning about. So again, I retired back in about 2017, I think it was, and I've been working with Envirotech Services ever since. And bless them, they are big on being industry leaders, and we do a lot of training. We train agencies that aren't even purchasing our materials. We think it's that important, and what you guys do is that important that if we can help any agency, we're there. So to keep that in mind. And John had mentioned we will come into your stations and train a station at a time. So we're big on that. So please take advantage of that. And then just the last thing I'll just say, I'm also one of the instructors for the American Public Works Association, the winter maintenance. I'm on the winter maintenance committee, and we offer trainings on right now I can't think of the name of the supervisor certificate program. And so I'm one of the instructors on that program. So always have to put this up. I'm going to be giving some numbers and some application rates and things that I've seen work. It's worked for me and my team. Agencies share information, what they're doing. But the bottom line, you guys know this as well as I do. Every storm is different. Every road is different. Every snowflake is different. And so when we're giving you numbers, application rates, we're giving you just general guidelines. And you're going to see, I think, on several of my slides, use the application rate that works best for you. And so that's the key. We're giving some guidelines, some maybe starting points, but it's really important for your agency to find out what application rates, what numbers work best for you, and implement those numbers. Whenever I'm talking winter maintenance, I always like to start off with kind of, remembering why you do what you do. And it's to avoid these nightmare scenarios of these pictures on the screen right now. The numbers are up there. I mean, 1,300 people killed annually on snowy, icy roads. That's that's a huge number. We also have, millions of vehicle hours of delay due to snowstorms and ice storms shutting down roads. It's well known through research that if you can return your snow and ice covered road to bare pavement, there's about an 85 to 88% reduction in accidents. So that's a huge number. And so that shows the importance of what you guys do on a daily basis. It's also been established in research that if a storm event shuts down a city, a county, a state, the the direct and indirect costs to that agency, small city, it might be in the tens of thousands. A large city or a state, it could be into the hundreds of millions of dollars of direct and indirect costs that agency, that state is going to lose. So again, I always like to say at this point, remember, you guys are first responders, and I often like to say you're actually before first responders, because if you're not out there doing your job, police, fire, ambulance, they're not going to get to the accidents and things they need to get to. So again, you guys don't always get the accolades that maybe the fire department gets, but you truly are first or more than first responders. And again, I always like to just say, now that I'm not a government employee, thank you for your guys' service. Really appreciate what you do. The public, they don't always say it, but the public appreciates what you do too. So our winter maintenance goals, we have basically two primary goals, and that's safety and mobility. We want to get people from point A to B, and we want to get them there safely. We want to do that without significantly impacting the environment. We have to accept the fact that any of the chemicals that we're using, and this includes sand and other materials, when we're putting materials out, there is an impact on the environment. And so we want to be good stewards of the environment and minimize any impacts that we are going to cause. So again, provide safety and mobility, minimize impacts to the environment. We want to do the above within our budget. And I'm going to venture to guess that nobody on this webinar has excess money in their budget. We need to provide the right level of service, which means addressing the social expectations of your community. And the only thing I'm going to say about that is, boy, that gets complicated. Every community has different expectations, levels of service, and social expectations that can be very political. So we could talk about that for hours, if not days. Let's just take it. It's a very complex, complicated process that varies from location to location. And again, you guys know this as well as I do, but winter maintenance, it's a system thing, because if you have to withdraw resources from one road, you're directed to take resources from one road to put them on another, you are impacting these other roads. So every decision we make, we have to look at it from a systematic point of view, because working on one road impacts other roads in your area of responsibility. And the reason I bring up all this brings us to a word, which is sustainability. And in society today, there's a huge push towards sustainable practices. That's the same in winter maintenance. The public expects sustainable practices. And one of the ways we do that is by implementing best practices. It's shown in research that if you implement best practices, that's a sustainable practice. And basically what we're going to talk about the rest of the day are best practices that will help you have a sustainable snow fighting presence in your local community. Sustainability, big word, scares some people. It actually is really quite simple. It just means you have a balanced approach to winter maintenance. We don't want to put all of our eggs in one basket. You don't want to put everything into the environmental basket. That can create an unsustainable process. We don't want to put, all of our things in saving money in the budget. So basically, again, it's just where we have a balanced approach between levels of service, economy slash budget, and in the environment. And when we have that even approach, we have sustainable snow fighting processes in place. Our selection of materials plays a role in sustainability. Products like enhanced liquids coupled with complex chlorides, as long as they're used as part of a comprehensive proactive operations plan, choosing the right materials can significantly reduce material usage. It can minimize wear and tear on your maintenance equipment. It can minimize personnel time on certain roads because you're going to be more efficient and more effective. But one of the things that it's really important to understand that if you are an agency that is just using granular material and you decide to add liquids to your toolbox, you don't stop using solids. You're going to just start using solids in a different way. And that is combining your liquids with your solids, pre-wetting, pre-treating the material before it goes on the road. And we're going to talk about that coming up here in just a little bit. So getting into the heart of winter maintenance best practices, it all starts with a winter maintenance plan. And it is really important for cities, counties, DOTs to have a well-written, comprehensive snow and ice control plan. These plans basically lay out all your strategies, your tactics, the resources you have available to fight snow and ice in the wintertime. It establishes, reason and authority. It lays out responsibilities. So really important stuff. And I'll say too, as a guy I had to sit in the courtroom multiple times representing the state of Alaska because of accidents on the road, and the state was being sued. If you have that comprehensive snow and ice control plan and you follow that plan, that's one of the best protections from liability that you can have. Multiple times I sat in the witness stand. I held up the state of Alaska's maintenance and operations guidebook. We proved we followed the approved processes that were outlined in our snow and ice control plan. And when we do that, most times we win that court case. So again, very important from a liability standpoint. And then the most important thing that is in your snow and ice control plan are your defined levels of service. Levels of service really should be at the center of our winter maintenance program because the written out levels of service should drive just about every decision we make when we're maintaining our roads. So again, very important to understand levels of service. It's very location specific. And what would work in Bellevue, Washington, would not work in Maple Valley, would not work in Moses Lake, and would not work in Auk Bay, Alaska, which is where I live half of the year. So again, important to understand that levels of service are road type specific. Obviously, a interstate should have a higher level of service than, say, a collector road, which should have a higher level of service than a residential road, which should have a higher level of service than a recreational road. So again, the defined level of service, which I like to look at it as when the last snowflake falls and you dispatch your trucks out on the road system, how do they know when they're done? Are they trying to get to bare pavement? Are they trying to just push back snow and ice and you apply traction material to snowpack? Depending on what your level of service is, that can dictate the type of materials and resources you need to take care of that road. If your level of service calls for bare pavement and you have temperature, your pavement temperatures get into the 20s or down into the teens, you pretty much have dictated that you need some sort of chemical so that you can get to that bare pavement. If you're willing to accept snowpack that's just plowed back with traction material, you probably don't need chemicals. You could get by with just applying traction material, sand or other abrasives. So again, level of service, really important, should drive most of the decisions we make in winter maintenance. When it comes to our goals, which are safety and mobility, the main way we do that in the wintertime is by providing traction. Summertime, it's generally not a problem. In wintertime, with snow and ice on the road, this is when we need to provide traction to get folks from point A to point B. There's a lot of different materials out there that we use to provide friction. First and foremost, there's the mechanical methods. That's using the plow. We have granular materials. That's sand, abrasives, salt, sand salt mixes. We have treated salt. We have complex chlorides, also called multiple chlorides, such as ice slicer. We have all the different liquids that we use. Calcium chloride, magnesium chloride, salt brine. But the one really key important thing to take away from this slide is that I will argue that mechanical snow removal with the plow, has been, currently is, and always will be the primary way we get rid of snow and ice off of our road system. Everything on that slide, with the exception of sand and abrasives, is geared towards making mechanical snow removal easier and more efficient. We're not trying to, when we use chemicals, we're not trying to just melt all the snow on the road or all the snow on the sidewalk or in the parking lot. We are using chemicals to either prevent or break the bond of the snow and ice from binding to the pavement surface. We want to prevent that from happening. That's anti-icing. If the snow and ice is already attached itself to the pavement, we need to de-ice it, which is breaking the bond. And we're going to talk quite a bit more about that. But a key takeaway, we do not use chemicals to burn snow and ice off of the road. We use chemicals to make mechanical snow removal more efficient and easier for our crews. And we do that by either preventing or breaking the bond on the road system. One of the things anybody that knows me knows I'm a huge advocate of life cycle costing. And to me, this is really an important thing. And the iceberg picture over on the right side, I think this tells the great story that the price of an object when we buy it, and that's whether it's a de-icer or a piece of equipment or office supplies or whatever it is, the price of an object or an item is just a small part of the overall life cycle cost of that product. So using an example of a de-icer, say you buy a de-icer for $1 a gallon, but you have to apply that at, say, 50 gallons per lane mile. So $1 a gallon, 50 gallons per lane mile. There may be another product that is $1.10 a gallon, but you only have to apply it at, say, 120 or 130 gallons per lane mile. Which is the most cost effective product? Now, we're all I think all of us on this call are with the government, and so we tend to have to do low bid. But what do you get when you do low bid? You get the low bid. So just really important, you need to look at the performance of products, the availability of products. Is it going to get you to your defined level of service? And just realize that the initial price, the bid price of an object, does not reflect the overall life cycle cost of that product. And products that have a higher bid price can actually, in the long term, be much more cost effective for you to use. And again, this is all about considering the life cycle cost, not just the bid price on that object. And again, really important, that's not just materials. That's, if you're buying graders, you're buying plow trucks, you're buying blades or wing plows, whatever it is, you need to look at the total life cycle cost of that item. So, like I said, mechanical snow removal, that's our primary way that we get rid of snow and ice. Part of my job with the Alaska DOT, I also oversaw the state equipment fleet. So I was intimately involved in ordering the equipment that we were purchasing. And we spent a lot of time looking at, the different platforms we had available to us: light and heavy duty trucks, graders, snow blowers, loaders, packers, lots of different snowplow platforms that we had access to. And we spent a lot of time reviewing that and deciding which platform, a truck or a grader, which would work best for us. We also have a lot of options for snow plows, for one way, two way, reversible, expandable, underbody, V plows. They're all have different uses, and I found, we as an agency, Alaska, spent quite a bit of time determining which of these plows were going to work best for us. The one thing that I think we and other agencies kind of failed at was plow blade technology has been changing rapidly. And I think, back in the old days when I started, we had steel blades. Then we had steel blades with carbide inserts, and it expanded. Today, there is a lot of different blade choices out there for us. Just two quick examples here. And I have nothing to do with these companies. No, this isn't an endorsement. This is just personal experience. But like in the upper left, the segmented blades, these can really help if you're using chemicals. These segmented blades can make your operations much more efficient, which can allow you to use less chemicals, because the segmented blades basically move up and down and adjust to the irregular contours on your road, that allows you to use less chemicals because your plows are more efficient. The other one I just wanted to bring up was the Shark Edge, which is the lower right picture. It's a great tool if you're into de-icing mode. These are very aggressive ice cutting blades. And the other thing I liked about them, one of my many duties with Alaska was I oversaw our safety program for the department. These blades can be changed by one operator alongside the road because they're light, they're manageable. We had lots of crushing foot injuries, operators changing steel blades. So not only do you get an aggressive cutting edge, but you also get a edge that can be changed out by one person a lot more safely than other blades. So again, just keep that in mind. Plow blade technology, there's a lot of blades out there. Take the time to do some research and see what they have. Next two slides, I'm a huge advocate. Think outside the box. Be willing to try something new. Be willing to try something new that might fail. I've had a lot of my brilliant ideas that turned into real duds and didn't go anywhere. Pretty proud of the fact that the Rayco icebreaker in the upper left there and the lower left, I discovered that on YouTube. I'm a YouTube fanatic, and I found that these are made in Finland. And we, Alaska DOT, were the first agency in the US to bring the Rayco icebreaker over. Worked, it's not a silver bullet, but it worked great for us. I had bought one before I retired. I think the state of Alaska now has 2 or 3 or 4 icebreakers in their fleet. The one in the lower middle, that's the Arctic Shark. That's an American made version. And then the blue one on the right, um, that's a homemade one that we made at Fairbanks International, uh, because the commercial ones didn't quite do what we wanted to do. And John, there in the picture, he took it upon himself to take the ideas of these commercial ones and make a better product. And man, this thing, which we called the Yeti, it was an animal, and it worked great for us on Fairbanks International Airport. So again, the point of that is think outside the box. I really thought outside the box, and I bought a jet engine to try and do away with frost and light snowfall on runways. I saw this at NASCAR. They use these jet engines to dry the track so they can get the race going. Well, if they can, heat up and evaporate the water on the track, why can't we heat up and evaporate the frost that's forming on the runway? So it didn't work exactly as planned. It is still being used from time to time, certain circumstances. Again, the whole point of this is be willing to try new materials, try new equipment, try new techniques. Things are changing rapidly, and technology is changing rapidly, and it's important to stay up on what's available out there. I always say provide the operators the tools, the mission, and then get out of their way and let them do their thing. Again, think outside the box, be willing to fail from time to time. And again, we all know customer expectations are not getting less, they're becoming more demanding. And I strongly believe the answer to responding to the higher demands from the public is to innovate. And so the more innovative that we can be as an agency, I think the better off we will be in the long term. Okay, we're going to move on now. We talked about mechanical snow removal with the plow. So now let's talk about salt. Some people call it rock salt. Some people call it road salt. This is basic sodium chloride. I'll probably call it just salt. I'll probably call it a bunch of different things. But anyway, sodium chloride salt is probably the most common across the country, the most common product used for anti-icing, de-icing. It is used in granular form primarily as a de-icer. It is used in a liquid form primarily as an anti-icer, and we're going to talk more about anti-icing and de-icing. Sodium chloride, and we're going to talk about this, has a effective temperature, which means it's a reasonable temperature that we can use it effectively on the road, of about 15 degrees. 15 to 20 degrees pavement temperature, and the eutectic temperature, which means the absolute lowest you can get it by adding salt to the water, is -6. For those of you that are using dry salt, you may not know it, but you actually already have a liquids program. Dry salt does absolutely nothing for us when it's in the dry form. Dry salt has to go into solution, has to go into a brine before it does it provides any benefit for us. So we can make salt brine where we're controlling the amount of salt in water, or when we're putting direct salt out on the road, we're letting Mother Nature provide the moisture to help the product go into brine. Salt requires heat, and moisture to go into brine. Too little heat, too little moisture. The process to convert into a brine can take a long time. If there's not, if it's more extreme, there's really not enough heat, there's not enough moisture, it may never go into brine, which means it's never going to work for you to do what you want it to do on the road system. So again, key takeaway, dry salt on the road does absolutely nothing for us. That dry salt needs to go into solution, and then it starts depressing the freeze point, which is the whole point of why we're using chlorides on our road system. So again, we use de-icers, we use anti-icers, basically consisting of chlorides, to lower the freezing point of water on the roadway. So in order for the material, the solid material to work, it has to first go into solution. So it mixes with the salt mixes with the water and starts, and it turns into a solution. And at that point, it lowers the freezing point of the water that's on the road surface. But a key thing is the second that brine starts working, it starts diluting because it's working. So it's starting to melt a little bit of snow and ice, and it's going to start diluting. And so we have to be very aware of that. This is the phase diagram for salt. And so we all know, and I'm going to try to be fancy here and use a pointer. We all know that salt freezes at 32 degrees. So the whole point of the freeze point depressant is if we start adding salt to this, it starts lowering that freeze point. So we add a little bit of salt, and now we add about 10% salt by weight. And now on a 20-degree pavement surface, that water is not going to freeze until at that level. So we can keep adding salt, and the freeze point keeps getting depressed. So again, this is kind of the whole key in this freeze point depressant, that the reason we use chemicals to lower the freezing point. So as an example, if we have 20% salt in our water and the pavement temperature is, what is this? This is 10 degrees. Once it starts diluting, this starts coming over here, and we don't have a very wide range of concentrations where that product is going to continue to stay in liquid form. If you go up the same 20, you go up to a pavement temperature of 20 degrees, we have quite a larger area of dilution where the product is still going to be working for us. So again, very, very key to just understand the importance of the freeze point depressant. And once the freeze point depressant starts working, it starts diluting. And at a certain point, it's going to exceed the freezing point, and we're going to start getting refreeze on the road system. So this is why we always say you don't just shoot and run when you're applying chemicals. You need to keep an eye on and make sure that, look at the dilution, make sure the pavement temperature is not decreasing so that you're losing less viable area. So and again, if anybody has any questions about this, it's kind of complicated. I mean, I could take a couple hours to explain this, but if you have any questions, please put that in the chat, and either John or I'll try to answer that better. But and then one of the other key things, if 23.3% salt is good, what about 30 pounds, 30%? More has to be better. But if you look at this, this curve comes down to 23.3% by weight of salt, and then it goes right back up. And so if you put too much salt out, you actually start getting refreeze, And if you're putting too much salt into a salt brine where you're actually spraying the liquid on the road, you actually are going to start plugging your nozzles, your filters, because the salt is going to start falling out of solution, and that obviously causes us problems in our anti-icing, de-icing trucks. Again, another key point, and this just shows the limitations of salt temperature-wise. So if you look at a road, a pavement temperature of 30, let me get rid of this pointers. Okay, sorry about that. So a pavement temperature 30, 1 pound of salt will melt 46 pounds of ice in 5 minutes. Now, if you only drop the pavement temperature from 30 to 25, it only now will melt about a third as much, and it takes twice as long. And so you can kind of look down the table, but this low response and the lower amount of melting, this is why we say, and you're going to hear me say this a few times during this webinar, that generally we do not use plain salt below 20 or 15 degrees. Different agencies some select 20 degrees, some select 15 degrees. In Alaska, we kind of cut it down the middle, and we were using 18 degrees was our lower limit for pavement temperature when we would use any salt. And again, another key thing, when we're talking a lot of temperatures, and we're always talking about pavement temperature, because that's where the interface is. That's where the snow, the ice is bonding. And so the pavement temperature is what drives a lot of our decisions when we're using chemicals on our roads. And I would say no agency should be putting chemicals out on any of their roads if they do not know what the pavement temperature is. Ambient air temperature is really important because that shows trends. Is the pavement temperature going to start declining? Is the pavement temperature going to start rising? But the decision making that we use for when and where to apply chemicals is all based on pavement temperature, because again, that's where the interface with the snow and ice and the pavement is happening. So that's a key takeaway, is to know the pavement temperature whenever you're using any liquid or granular material on your road system. So just some final some salt application thoughts. Generally, salt is applied at anywhere from 150 to 500 pounds. The big variation is because, again, every storm is different. Could be wet snow, it could be dry snow, could be heavy snow, light. So there's a wide range. And this is why it's important for your agency to find out what application works best for you. White salt should be limited to 15 to 20 degrees pavement temperature. We're going to talk a lot more about bounce and scatter, but a salt coming out of the back of a truck is going to bounce and scatter. And so one of the best practices, and we're going to talk a lot more about this, is to pre-wet or pre-treat the salt that comes out of the back of your truck. So we're going to talk more about that. One of the words of advice I give to folks that are using salt, and this applies to sand, is turn the spinner off or put it at the lowest spin rate you can possibly do it. Use the crown of the road to your advantage. Place the material at the high side of the road and let gravity move the material across the roadway. Chutes like in the lower right work great because they put the material right down on the pavement, right where you want it. So again, spinner off or at very low setting. Chutes can help deliver material right where you want them on target. and watch out for your speed. And I'm going to show you some videos here in a little bit about the importance of speed whenever you're putting out sand or salt out of the back of your truck. You're using salt, you do have options. There are, and I look at this as kind of good, better, best. So sodium chloride is good. It has its place. It melts snow and ice down to 15 to 20 degrees. It's probably the least expensive of the salt products. The better is treated salt. You can treat the salt yourself in a stockpile, or you can purchase treated salt from several vendors. That's the better. And then the best is the complex chloride, also called multi-chloride. That's a product. That's Ice Slicer. Ice Slicer has the advantage that it has the 4 primary chlorides built within each granular, basically, of the Ice Slicer. So Ice Slicer has sodium chloride, potassium chloride, calcium chloride, and magnesium chloride. So it is a really powerful tool, and I think a lot of the folks on this webinar use that product, and I think would agree that it is a very powerful tool for us to use. When talking about treated salt considerations, again, you treat sodium chloride with calcium chloride or magnesium chloride, and it does reduce the effective temperature of that salt. So that's a good thing. Salt is pre-treated ahead of time, so you're putting moisture on it. So it is going to go to brine quicker, and it is going to be reduced bounce and scatter. We're going to talk more about that. But treated salts, you really have to be careful about the leaching potential. And you can see the pictures here. Some materials that contractors use can leach. And so you have to be very careful about that. And then another really key thing is when you're treating road salt with magnesium chloride, say, you're only treating the outside of that granular. So what melts first? The outside of the granular. So your magnesium chloride is going to melt first. And once it melts, the center part of that granular is just sodium chloride. So you are losing the benefit of of treating it. You're not treating the entire granular. You're only treating the outer portion of that. So you're not getting the full benefit of the mag chloride that you're putting out. And even what I tell folks, and not everybody agrees with this, but even if you're purchasing a treated salt, or if you're treating it yourself in the stockpile, I still think you need to pre-wet it in the truck before it goes out onto the road, because most vendor provided treated salt only has about 3 to 5 gallons per ton. And you're going to see later on, our ideal amount coming out of the back of our trucks should be treated with about 20 to 30 gallons per ton. So anyway, food for thought if you're using treated salt. So what is a complex chloride? What is a multi-chloride? I touched on that earlier. This is Ice Slicer. It's about 90 to 96% mag, calcium, sodium, and potassium chlorides. A key thing is it has all these natural inhibitors that it's just naturally in the product that reduces corrosion. And it's these environmental buffers that are really important, again, for sustainable snow fighter practices. Typical application rates of Ice Slicer are about 30 to 50% less than typical white salt applications. I think I had said typical white salt applications were about 150 to 500 pounds per lane mile. Typical Ice slicer, what my experience is in the 100 to 350. So you can see it's definitely a lower application rate for a product like ice slicer. One of the other key things about ice slicer that is really important is the gradation. Sodium chloride, generally, if you're buying just rock salt, road salt, they're pretty much the same size material, which means they're all going to melt pretty much at the same speed. One of the advantages of a product like Ice Slicer is it has a gradation, just like a base course or something when you're building a road. It has fine material, medium sized material, and larger material. So the smaller material, again, it's going to go into brine a lot quicker and start working immediately. And then you have the different sized material, so it will last on the road longer. You get the initial fast brining from the fine material, and you have the longer lasting, larger material that will melt the snow and ice for a longer period of time on the road. So again, to me, this is one of the key differences of Ice Slicer to others is the gradation of the product. Some just summary salt don't do's, and this applies to all three types of salt: sodium chloride, treated salt, and ice slicer. Don't apply when it's too cold. uh, Again, we showed you the phase diagram chart, and the colder the pavement temperature, the lower the window of concentrations that will work. So you don't want to put it out when it's too cold because you risk the possibility of a quick refreeze. Don't spread beyond the traffic lane unless your levels of service states you want shoulder to shoulder, not just fog line to fog line. But a good practice is we shouldn't need to be chemicaling our shoulders. We should worry about fog line to fog line, which is where the traffic is. So that helps us minimize the amount of chlorides that we're putting out into the environment. Do not apply and plow off. I have actually driven down the road, seen a salt truck putting salt out on the road. Within 5 minutes, here comes a plow truck behind, plowing all of that unmelted. It hasn't had time to go into brine off onto the side of the road. So you got to be sure you're giving your product time to work. Again, it's all about the bond, breaking the bond or preventing the bond. We're not trying to just burn snow and ice off the road. Don't apply to too cold or dry pavement. Again, we need heat, we need moisture in order for that product to go into brine. And when you see a wet road, your job is done. You don't need to apply any more salt if you already have wet pavement, because that is our goal, is to depress the freezing point so that water does not freeze. So again, wet road, your job is done. And then just some final thoughts here on granular salt. Said a lot of this before. Again, dry salt is limited to about 15 to 20 degrees pavement temperature. Ice slicer complex chlorides have been successfully and are continually successfully applied at pavement temperatures down to 0 degrees Fahrenheit. Adding more salt does not speed up the melting process. That's a really key thing too. People think, it's not melting fast enough, I'll just throw more salt at it. Adding more salt does not speed up the melting process. Talked about granular salt is subjective to bounce and scatter. And because when you put a solid material down on the road and traffic is going to be driving over it, it may not be the best product for anti-icing or for early de-icing, because by the time it actually starts working for you, you may already have lost a lot of that product outside of the fog line onto the shoulders. Again, a key best practice, and we're going to talk more about this, is solids, whether it's sand or salt or a sand salt mix, should be applied pre-wet or pre-treated. because that jump starts the brining process, and that minimizes bounce and scatter. I get asked this a lot too about, you know, and I dealt with this in Southeast Alaska. A lot of our storms were it's raining. It starts, you know, it's rain, rain, rain. Snap your fingers, temperature drops, and it goes from rain to snow. And so that's a really tough one for liquids to handle sometimes, because I've done this. The forecast was at 3 o'clock it's going to change from rain to snow. So at 5 minutes to three, we go out and we put out 3,000 gallons of uh, uh, Apex out on the road system. Well, it doesn't turn to rain at 3 o'clock. It didn't turn to rain till 4 o'clock. There's 3,000 gallons of meltdown Apex in the ditch. So again, solid material works best for events that start as rain and go to snow. Solids work excellent for snowpack, for de-icing, and they work very well for freezing rain events. So again, be very aware. And part of the reason for this is when you're putting down a liquid product, you're only putting down between 24 and 32% product. The rest of it is basically water. And so again, you're the possibility of quick refreeze, because you know you're going to have water on the road because of the rain that was there before it turned to snow. So again, just be very aware that solid products are essentially like almost 100% active product. Liquids are only about they're 34 to 32% active products. So again, an important takeaway. Okay, we'll do one more section here, and then we'll take a break. So let's talk about sand and or sand salt mix that some agencies are doing. I have to say, you know, with my DOT hat on, we used a lot of sand in Alaska because we were dealing with 30, 40, 50, 60, 70 below zero temperatures. None of the chemicals that we had available to us for the road system were going to work. So we did use a lot of sand. So it definitely has its place. A lot of people think sand is the least expensive product that we can put out on the road. I'm going to argue that that's not necessarily the case. A truckload of sand, since we put sand out at higher application rates than salt, the trucks don't go as far. So the trucks are going to be coming back to the shop to refill up more often, more fuel, slower cycle times. So there's a cost to that. There's a cost to cleanup. So when you put sand down, after a while, what happens? Where does it go? It goes on the shoulder. It goes in your culverts. It goes in your storm drain systems. It goes in your ditches. It goes under your guardrail. So these are all costs that we really should be including in. When we use sand, there's cleanup costs. When we use sand, there's environmental costs. So we need to consider all these. It's the whole thing about life cycle costing. You guys probably know this better than I do. Sand is very temporary. Certain number of cars, especially faster speeds, and that material is going to bounce and scatter off of the pavement out onto the shoulder. So when we apply salt, particularly products like Ice Slicer, you probably only have to do that once a shift. When you're using sand, you might have to apply 2 to 3 times a shift. There's a cost to that you need to take into account. This is a picture I took in Alaska. We used 3/8 inch because we did a lot of chip sealing. So we used our 3/8 inch chip as our sand product or our abrasive product. But if we don't get in there and clean out under the guardrail, what's going to happen when it rains? Water's not going to drain off the road. It's going to drain down the road. what is asphalt pavement's worst friend? It's water. So we need to clean out under the guardrail. There's a cost to that. Again, these are from snow blowers blowing. This is an environmental issue. Again, sand ending up in creeks, ending up in our storm drain systems. There's health issues with sand, people that have breathing issues, asthma, COPD. There are health issues with using sand. And one of the other things, and I'd be curious if you guys would maybe put in the chat box if you're using sand salt mixes. And if you are using sand salt mixes, are you using a 10-to-1, 50-50? I'd be very curious about that. And then maybe, John, if we get any responses, you could jump in and let me know what that is. But so I will tell you, I'm not a fan of sand salt mixes because, like I said earlier, our level of service should drive the decisions that we're making. If we have a bare pavement policy, sand is doing nothing for us in terms of reaching our level of service. If our level of service is snowpack with sand applied, traction material applied, there's no reason to be putting the salt out in general. So one of the things I tell people, when you're doing like a 50-50 sand salt mix, you are always 50% wrong because you are not addressing your defined levels of service. Now, in full disclosure, we did do a 3-to-1 sand salt during certain ice storm events. The roads were so icy, we couldn't even get our trucks out on them. So we had to sand. We wanted sand for instant traction so we could do our job. And then we put salt out so that we could get the melting to get started. So again, we probably did that once or twice a year at most. But again, you think about what your level of service is, what is your target, and again, there's just lots of issues with the sand salt load being a very confused load because it doesn't know, is it providing traction? Is it going for melting capacity? So John, did we get any input?
Not at this point.
Okay. But I'm going to move on, but if you wouldn't mind, I'm always interested in learning what agencies are doing and how it's working for them. So please, if you're using any sand salt mix, let us know. And then kind of to wrap up, again, sand and sand salt mixes, they have their place. So with sand, it's the most common material used. It's the least costly up front. It can be used in any type of weather, which this is a great thing about sand, is it can be heavy snow, light snow, black ice, freezing rain, cold temperatures, warm temperatures. It can be used in any kind of road condition, which is a real benefit of sand. They're excellent choices for extreme cold events, for gravel roads, for hills, curves, intersections. It's great for low volume roads that have low levels of service. And the negatives of sand, as I've been saying, it's not an active material. It doesn't melt anything. The traction is temporary. A certain number of cars run over it, and it's going to bounce off of the road. It's not going to be working for you. There's environmental and cleanup hazards and costs. What may seem like the least expensive, when you look at the life cycle cost of sand, it may actually be a higher cost than the other options that we do have. And then again, best practice, if you use sand, if you use salt, if you use a sand salt mix, get it wet before you put it out of the back of the truck. One of my goals with the state equipment fleet in Alaska, I did not want a single product coming out of the back of any one of our trucks that wasn't pre-wet or pre-treated. I didn't get there before I retired. I think we made pretty good progress. Um, but again, I just that's a industry best practice that is taught all across North America and Europe is sand salt mix, get it wet before it leaves the truck. I think this is a good place to take a quick break. Um, I've got a little wordy, so I'm going to just try and keep this to maybe like about a 5 minute break, get some coffee, run down the hallway, do what you need to do. Again, if you have any questions, comments, please put those in the chat and I will address those before we get started back. So let's go ahead and take 5 minutes here real quick and then we'll get started back up again. So about another minute or so and we'll start back up.
Just to echo what Mike asked, this would be a great time. If anybody, you could even feel free to unmute or turn on your camera. If anybody has any questions about anything we've covered so far, now's a great time to chat, or the chat box is available. John and I will be watching that. So appreciate everybody being here, and let us know if you have any questions or comments. We always like to hear best practices from you folks too. That's how we learn. Go ahead, Stephen. You have something for us? Go ahead and unmute.
I was just waving to the Post Falls guys.
All right, who wants to talk about liquids? Turn it back to Mike.
Okay. So, yeah, I mean, why use liquids? So, one of the, I started off by talking about dry salt does nothing for us. It has to be in the brine, it has to be in a solution. So, kind of thought is, well, why not just, instead of waiting for Mother Nature to do that on the road, why not just make a brine right off the bat, so that the second that liquid material leaves the back of the truck, it's working. It doesn't need to wait for Mother Nature to, provide heat, to provide moisture to convert that into the solution so that we can actually start melting, breaking the bond, preventing the bond. So again, one of the other key things here is, again, from a sustainability point, we want to get to our defined level of service while using the least amount of chemical that we can possibly use. That's sustainable snow fighting. And so just a little bit of math here, but it makes a point. So the eutectic temperature of salt brine is -6. That's the lowest temperature you can get by adding salt to where it's gonna stay as in liquid state. Below -6, it starts to freeze. That is done at 23.3%. So if you take 2.54 pounds of salt per gallon, that's what it takes to get the 23.3. So the best mix you can get is 2.54 pounds per gallon. Convert that into amount of gallons per lane mile on a typical application. Typical salt brine application, 30 to 50 gallons per lane mile. So you take the 2.54 pounds that goes in per gallon times 30 or times 50, and that gives us 76 and 127 pounds of salt per lane mile. But what's the typical salt application per lane mile? That's 150 to 500. So by using a liquid, we are able to use a lot less of the chemical to get the same results. And that is a very sustainable practice. It's something that you can highlight to the public, highlight to your city or county assembly. We are being very efficient, and by using the liquid, we're putting out a lot less material onto the roadway, and we're still able to get to our defined level of service. So again, to me, that's an important takeaway. So the different ways we use liquids, Lots of options for us. There's de-icing, which is the traditional method of dealing with snow and ice on the road. Basically, we would wait till there's an inch, inch and a half, 2 inches, 3 inches, whatever that number was. We dispatch our trucks, but the problem is before our trucks get there, the public has been driving cars over the snow and ice, and it is now compacted and it is bonded to the road. So we now have to go in and break the bond, which, as you're going to hear, takes 4 times as much material to break the bond as it does to prevent the bond. Anti-icing. It's a proactive approach that we do. We're applying material directly to the road surface, typically done with liquids, can be done with pre-wet solids. We could be out on a beautiful sunny blue sky day putting this material down because there's a storm coming in 24 hours. And so we are being proactive. We're out ahead of the storm. And because we have that anti-icing material down, that buys your crews some extra time to work on other roads, complete other job tasks at the beginning of the storm, because you have time before the snow and ice is going to bind to the road. So again, de-icing is reactive after the snow is bonded to the pavement. Anti-icing is proactive. It is preventing the snow and ice from bonding to the road surface. We have pre-wetting, which is basically just mixing our granular material with our liquid material before it goes out of the back of the truck. We have different ways we can do that. We can purchase pre-wet, pre-treated material from vendors. We can put it up ourselves with a pug mill into our stockpile. We can add chemicals to that. Probably the most common is pre-wetting on board the truck. We can either do that at the spinner, we can do that at the auger. In the old days, we used to use shower systems where you load up your truck with salt, you drive under a spray bar, and it's spraying the chemical from above. There's a lot of problems with that regarding bridging, and you don't get a good mix of material. So that is no longer recommended. And then finally, there's high volume output, some almost like a slurry. One of the things, a way I describe this, it's kind of crude, but it's like an incontinent cow going down the highway because it's just kind of plop, plop, plop. You're using a high quantity of liquids with a lower quantity of solids to get that slurry basically out on the road system. And again, as I've said many times, we're not using chemicals to burn off snow and ice. We're using the chemicals to make mechanical snow removal easier and more efficient for us. So anti-icing, de-icing, what's the difference? Anti-icing, proactive, de-icing, reactive. Again, it takes 4 times the amount of material to break the bond as it does to prevent the bond. So this is a very sustainable practice, both from a budget perspective, from a level of service perspective, and from an environmental perspective. So again, much more efficient to prevent the bond than it is to break the bond. And another key thing here is, see if I can get my pointer back. Here we go. All we're trying to do on anti-icing is to keep this so it's not letting the ice freeze to the pavement. We're actually only melting about, I think it's like 3/1000th of an inch. So very little to get the benefits of anti-icing. Now on de-icing, the reason it takes 4 times as much material, again, we're not trying to melt this material off. we're still trying to melt this down here, but we now, when we're de-icing, we have to get the liquid or the solid all the way through this snowpack down to the pavement to where it can spread out and we can actually start removing the product or the snow and ice. So again, uh, all we're worried about is this interface between the ice and the pavement, and that is our target in anti-icing and de-icing. Again, I just like to use the example anti-icing. It's like putting butter or olive oil or Pam in your dish so that the egg doesn't stick when you're making your morning breakfast. Picture on the left looks excellent. That is exactly the pattern I think you want to see when you're putting down anti-icing material. You want the spray bars about 12 inches to 18 inches apart. So you got dry material with traction in between each of the anti-icing lines. So that's an excellent example of what it should look like when you're done anti-icing. Lots of different equipment out there, from truck inserts, tanker trucks. We use the tow plow to apply in chemicals over 2 lanes. Again, this is another good example. I took this picture on the Kenai Peninsula in Alaska, a good spray pattern on the road. This was a salt brine application. So kind of summarizing anti-icing, it's a proactive strategy. It involves applying a chemical freeze point depressant, typically a liquid, but can be done with pre-wet solids. The material is placed directly on the pavement surface. Anti-icing prevents snow and frost from binding to the road surface. Prevents frost from forming on roads and bridges, which is very important. Oftentimes, agencies, particularly when they're just getting started in anti-icing, they are anti-icing hills, curves, intersections, bridges, and other main roads. And again, anti-icing buys your crew some time at the beginning of the storm because the material is not going to stick to the pavement, and it allows you to do other things and still get back there and take care and do a good job of plowing after the anti-icing material is applied. Just a rough, when do we anti-ice? So, anti-icing is great for frost prevention. So if you have frost predicted, that's a great time to anti-ice bridge decks, hills, curves, intersections, shaded areas. If you have snow forecasted, as much anti-icing as you can, as long as that is addressed in your levels of service in your snow and ice control plan. And then a lot of, particularly DOTs, they're using, National Weather Service or private meteorologist recommendations. They're using maintenance decision support systems. So whatever the your weather service is telling you to, where to anti-ice. Again, you need to figure this out. Each area is different, but this is kind of a good standard for when to anti-ice. Again, like I said, liquids are great for frost management. You can use very low application rates, as down as low as 10 gallons a lane mile, and you can get multiple days of frost prevention. We only had one guy working on weekends when I lived in Juneau. And so we tended to put material down. We'd put mag chloride down on Thursday or Friday, and that would last us through the weekend under the right circumstances, to where when we had a full crew on Monday, we could address things again. So again, liquids are outstanding for frost prevention, instant results with minimal use of chemical. Here's an anti-icing, a frost prevention application. They're down to 15 gallons per lane mile. You can see that it's not snowing on the road. Looks like there's blue skies. So a good frost prevention application. De-icing, it's a reactive strategy because the snow and ice is already bonded to the road. We need to get through the snowpack with our chemicals to break the bond so that we can send our plow truck across, and the truck is going to be more efficient and effective than if we had not put any chemicals down. Again, 4 times the amount of chemical to de-ice as it does to anti-ice, because you need to break through the snowpack to get down to the pavement. De-icing historically is done with granular materials, but it can be done with liquids. There are agencies that are moving towards liquid only routes where they're using liquid before the storm, during the storm, and after the storm. And that's I can talk to people offline about that. That's a whole nother subject, very detailed. And again, I've said this probably 5 or 6 times now, we are not burning off snow and ice. We are using the chemicals to make manual snow removal easier and more efficient. Just a general tip for those that are using liquids for de-icing, you want to have enough bar pressure so that your stream of chemical, you can kind of cut grooves in the snowpack that helps you get down to the pavement quicker. And then we always want to avoid the fan spray. Particularly, we don't fan spray on anti-icing, and we particularly don't want to fan spray on de-icing, because you can end up with the Zamboni effect where you have, a light film of water over the surface of the snowpack. That's going to refreeze. That's going to cause an icing problem. I call it chemical ice, and dealing with chemical ice is much more difficult and much more challenging than dealing with Mother Nature ice. We always want, before we're de-icing with whether it's liquids or granular material, plow. We want to get as much material off with the mechanical methods as we can so that we can minimize the amount of chemical that's needed to go through the snowpack to get down to the pavement to break the bond. So again, plow, use chemicals to help, but try to minimize the amount of snowpack that the chemicals have to go through. I like this picture. I just use this as an example. The plow is down in the front of the truck. He's using a streamer nozzle. Looks like it has pretty good pressure. You can see the lines in the snow behind him. So we want to see the plow down to minimize the snow that the chemicals are going to go through. We want to see a good, powerful spray coming out of the spray bar to help get the product down to the pavement as fast as possible. When we are de-icing with liquids, we need to be very careful. We tend to want to do it with warmer pavement temperatures, low or no additional snowfall. We want short cycle times, and we want no blowing snow. And the reason for all 4 of those is dilution. If we have extra snowfall coming, that's going to help. That's going to cause things to dilute out quicker. We need shorter cycle times so that the chemical doesn't have a chance to refreeze on the road system. And then I'll show you, I got some pictures coming up of blowing snow and what can happen there. So again, it's mostly about refreeze. We just want to be very careful, so we do it with warmer temperatures and when we're not expecting any or much, if any, more snowfall. And liquids are not always would be the choice, particularly in situations like this. I can just tell you the picture on the right. That's Fairbanks, Alaska, around Christmas a few years ago. Pavement temperature was well below zero. Air temperature was 40 below. Snap the fingers, the air temperature went to 40 above, and it started raining. And we grew about 2 to 3 to 4 inches of ice on every road in the Fairbanks area, and we fought that for the next 4 months until it all finally melted out in the spring. So anyway, liquid de-icing is a tool. We just got to be very careful, and we got to use it in the right circumstances. Okay, we're going to talk about pre-wetting, pre-treating. Why do we pre-treat? Why do we want to pre-wet? Okay, we talked about dry salt does absolutely nothing for us. It needs to be in a brine form. So why not help Mother Nature along? Why not get some liquid on our granular material before it goes out of the back of the truck? So we're jump starting the brining process. It's a proven fact that wet material coming out of the back of your truck bounces and scatters less, as much as 20 to 30% less than dry material coming out of your truck. So you can save 20 to 30% more material because it's going to stay on the road between fog line to fog line. A key thing about this is if you are starting a new pre-wetting program and you want to recognize that 20 to 30% savings, it doesn't happen magically. You need to reduce your application rate at your controller by the 20 to 30% that you want to save. I've seen agencies put saddle tanks on. They don't adjust their application rate, and we're not saving anything. Again, you have to adjust the application rates on your truck to actually benefit from the reduced bounce and scatter. If you're pre-wetting sand, and you're putting that sand on a snowpack, it tends to melt into the surface of the snowpack, and then it refreezes, and so you get that nice sandpaper action. So that's a real benefit to us. If you are pre-wetting with magnesium chloride or calcium chloride, you are able to reduce the effective temperature. So instead of limiting salt usage to 15 to 20 degrees, if you pre-wet it with mag chloride or calcium chloride, you might be able to get that down into the middle single digits by benefiting from the mag chloride or the calcium chloride. Reduce environmental impacts because you're putting out 20 to 30% less material. And this is a great example of how you can do more with less by implementing best practices. I'm going to skip over this one. One of the other key things, pre-wet is a huge benefit to keeping product on the road. The speed of your application truck is absolutely critical. And, just because your truck can put salt out at 50 gallons per lane mile, at 50 miles per hour, doesn't mean you should be driving that truck putting, whether it's solid material or liquid material out. You don't want to be going 50 miles an hour. This MDOT study, they found the sweet spot was 25 miles per hour. That kept the most salt in the target zone, fog line to fog line, with the absolute maximum speed that you should be operating at, which is 35 miles per hour. So again, 25 miles per hour sweet spot, and 35 miles per hour would be the upper limit for them to be as efficient as you possibly can be. I'm going to show you a great video here. This is from Washington State DOT. They set some cameras up, and then they're putting down some pre-wet and not pre-wet salt on the road, and you're going to see the difference between pre-wet and slower speeds. And when you have a higher speed truck putting down dry material, I think you're going to be amazed at the amount of material that just instantly goes off the road and is lost to us. And I also have to always say, because I'm a music guy, I did not pick this music. Bear with the music on this because I think it's horrible. But here's this WashDOT video on pre-wetting and speed. And I'm going to skip ahead just a little bit here. So this is what I had said earlier about using the crown to your benefit. So 25 miles per hour, no pre-wet. And you're going to see two different angles of this. Everything outside the fog line is essentially lost. So now here's the 25 miles per hour with 15-gallon pre-wet. And again, I think that's a huge difference. So high speed, no pre-wet, and look at that. Again, to me, this is one of the most powerful videos I think I've seen on the importance of pre-wetting and reasonable speed on our distribution trucks. Okay, and this, they're putting sand down here and it's not as visible, so I'm going to skip over that. So, but anyway, I'd be curious what you guys think of that. It's a pretty telling video about the importance of, again, pre-wetting, the importance of keeping a reasonable speed when we're putting down salt. That would apply to sand, pre-wet sand or dry sand too. So, so our other options on liquids, we can purchase treated salt from vendors. We can do this ourselves in the stockpile with a pug machine like it is here. You can see the application, typical application for pre-wetting material or pre-treating. And just real quick, typically we say pre-treating when it's in the stockpile. We say pre-wetting when it's on board the truck. So, but those words do get used interchangeably. So the other most common way we get our material wet, it's pre-wetting on board the truck. Historically, agencies were at about 8 to 12 gallons per ton. Recent work shows that 20 to 30 gallons per ton is very successful. I believe WashDOT is shooting for around 19 to 20 gallons per lane mile. Correct me if I'm wrong, if somebody knows something different than that. Again, typically at the auger or at the spinner. And then again, kind of why do we pre-wet? Because we don't want that material outside of the fog line right as it leaves the truck, because again, that does nothing for us when it's outside of the traveled way. So again, really important. Pre-wet minimizes bounce and scatter by 20 to 30%. That means less sand in the ditch, under guardrails, and storm drains, less spring sweeping. We can improve granular performance by pre-wetting it with a mag chloride or a calcium chloride. And we can reduce application rates because not as much material is bouncing off of the road. So that's a money saver, and that is it's a benefit to the environment. So we have lots of different products to choose from. We've talked about anti-icing, de-icing. pre-wetting, pre-treating, and there's options. The big three are salt brine and enhanced salt brine, and mag chloride and enhanced mag chloride, and calcium chloride and enhanced. And so I put up there, our for Envirotech, our salt brine additive is AMP. We have Meltdown Apex and Meltdown Inhibited, which are our enhanced magnesium products. And then we have CC calcium chloride with Boost and Apex C are our calcium products. And just, I should have said this early on, these are the products we provide. There are other products on the WashDOT contract, but these are the Envirotech service products that that you have access to at this time. So again, we talked about sodium chloride quite a bit. Most commonly used product in terms of liquid, it is 23.3% sodium. That gives us our sweet spot. Again, it's that 15 to 20 degree pavement temperature effective range. Mag chloride, it tends to be it's about 30% mag. That varies a little bit up and down. Most of the mag chloride in North America is produced from the Great Salt Lake brine. I just put this in here because I think this is pretty amazing. It's an aerial view of Wendover, Utah. You can see these are the evaporation ponds for the mag chloride. Huge, 3 miles by 4 miles, and then they go through a series of chambers. I just thought you might be interested if you're using mag to know how that's produced. Calcium chloride, it generally is a liquid product that you buy from your vendor. It runs about 32%. Calcium chloride has the really low eutectic temperature of -60. And I'm going to say I don't necessarily agree with the -25 for an effective temperature. I think it's a little bit higher than that. We move a lot of material across the Great Lakes. This is our dock on one of the Great Lakes. I can't even remember what state it's in. Old man memory here, but this calcium chloride. And again, we have lots of options. And I get asked a lot, do you recommend calcium? Do you recommend magnesium? Do you recommend salt brine? And it's a very personal decision. One of the major differences between the three main products is operating temperature. Again, salt brine's limited 15 to 20. Magnesium chloride, calcium chloride can certainly go down into the single digits and potentially lower than the single digits, below zero potentially. And calcium chloride and magnesium chloride tend to have lower application rates, considerably lower than straight salt brine. One of the things I always tell folks is look at the effective freeze point at 1:1 with water. So we talk about how important dilution is, dilution of the solution. So you put the product down, it starts diluting. So when it's diluted, basically 50%, and you have 50% water, 50% of the original product that went down, this tells us a lot. So when we're partway into the dilution, you can see I'll call it the power of the different products, with the Meltdown Apex having the lowest effective temperature at the 1:1 with water point. So I would say, if you're buying from us, make us provide this information to you. If you're buying products from other vendors, to me, this is a really important fact, because dilution plays such a big role and impacts our operations a lot. So it's really good to know this effective freeze point at 1:1. So we're getting close to the close time. I'm going to just zip through salt brine basics because it is such a common product. We've talked about the eutectic concentration, the eutectic temperature. One of the key things about salt brine is it's not hygroscopic, which means it does not suck moisture out of the air. Any of you that have ever used magnesium chloride or calcium chloride for dust control or stabilization, you know those are hygroscopic chemicals and they draw moisture out of the air. And that's why they are such good dust control stabilization products, because they even in the driest desert, there's usually moisture in the air, and products like mag and calcium that are hygroscopic, they are able to draw that little bit of moisture out of the air to help keep the dust down. And then one of the other real benefits of using salt brine is it mixes very easily. You can hot brine with adding mag chloride. You can hot brine using calcium chloride. And then we have a product called AMP that is outstanding and works really well, brings a lot of things to the table. So again, sodium chloride plus water is the basic ingredient. The magic number is 23.3% by weight of product. Making salt brine does not have to be a multi-million-dollar operation. This is from a colleague of mine, Mark DeVries. He had the opportunity to go to Argentina to work with the government to help them improve their operations. This is how they made salt brine. 55-gallon drum and a homemade steel paddle. So, and it worked for them. Lots of different manufacturers out there, lots of different styles of salt brine machines. Technology is advancing greatly in salt brine making machines too. So things are, look into it. Things are changing rapidly. This is in Fairbanks, Alaska. We started with 2,000 gallons. Salt brining was so beneficial to us. We now have 20,000 gallons of very heavily insulated tanks to hold our salt brine. Do we salt brine year round? No. Or all winter? No. We salt brine in the fall. We salt brine in the spring. And what we found, most of our accidents and fatalities were happening in the freeze-thaw cycle early in the fall. And so we've been able to bring the accident rates down because of our proactive anti-icing program that we're doing in interior Alaska. I'm going to skip over that. Key thing, salt brine is a great product, but it is prone to drying out because it is not hygroscopic. You can see the dust cloud of salt behind the truck there. It requires frequent reapplication, both because it dries out and because the lower temperature range that it works at. And salt brine alone, without any additives, is one of the most corrosive products there is. So again, the answer is salt brine enhancers. This is just our AMP brochure. If anybody's interested in, you're making salt brine or you're interested in salt brine, please get with Jason or John following this, and they can get you lined out on more information on AMP. Lots of benefits. My number one benefit of using AMP is the tacticity that it provides. So one of the things it acts like a sugar. And I like to use the example. I tell folks, take a can of Coca-Cola, spill it on a table, let it dry, touch it, it's sticky. Those are the sugars in the Coca-Cola. So what we want is by adding a sugar or polymer-based product that acts like a sugar, the salt stays on the road. The salt does not blow away. So that tacticity allows the product to work a lot longer before reapplication is required. So that's to me, that's an absolutely huge benefit. This was a trial we did in Fairbanks using AMP, salt brine. You can obviously see which side of the road was treated. This was done air temperature 9 degrees, pavement temperature, I believe, was 6 degrees. I may have that backwards, but we applied the AMP, 20% AMP in the salt brine, and we had a dry road for 3 days. So again, very successful. Different application rates. This is for salt brine, wide range, 20 to 90 gallons per lane mile. Depends if you're anti-icing or de-icing. I think a real average number that I'm aware of is in the 30 to 50 gallons for salt brine. I'm not going to go through this decision tree, but this is for salt brine. If you're using calcium chloride with Boost, you're using Meltdown Apex, you're using CCB, Apex C, you could make this decision tree yourself. If do we have a storm coming? If yes, what's the temperature of the pavement? If it's within reason, what's the humidity? So having these decision trees and following through on these decision trees, I think it's a great thing. And any chemical, you can make up your own decision tree for when is the best time for us to make the application. Okay, I think it's 10 o'clock, so I think this is probably a good place to stop. I'm going to actually move this ahead here real quick. Sorry, because I want to get the phone number up here. So I'm sorry I didn't get to everything. We got a little bit of a late start with some technical difficulties. Happy to schedule another training session to finish off on the 20 slides or so I didn't get to. And again, like both John and Jason said, we do these virtual ones. We've been doing this once a year or twice a year for the last several years, but we do a lot of training in your maintenance station. So we'll come right to your shop. Again, we love to do the training. We pride ourselves on being industry leaders in this, and it's whether it's our product or not, we want you guys to have the best information, the best chance for success in your anti-icing, de-icing, road maintenance processes. So with that, maybe John and Jason, you might pop back in here, and did we get any questions at all or any comments?
No, we got nothing on the chat. Just so you guys know, looks like we fat fingered my phone number there. Should be 509-290, should be 2328. Most of you have it already. If not, my email address is down there. You can email me. That has my contact information on it as well when I send them one back. So, but no question or anything, Mike. Guys, feel free to unmute at this point if you want and ask away or make comments. Go for it. It's all you.
And let me just say too, I want to know if this is worthwhile. I mean, I've been doing this for 45 years, and I want to keep improving. And so whether you say something now or send us an email, hey, I would really like to have seen this talked about or something like that. We want to keep improving this and making sure we're giving you guys what you need. So we'll take any constructive criticism. So anyway, with that, yeah, any comments of any kind, questions, success stories you want to share with the group?
A quiet crowd today.
You guys are an easy group. You're not putting us on the spot.
This virtual format makes it tough for folks. I know it's a lot of people aren't comfortable speaking up, but to Mike's point, you can get a hold of us anytime, whether it's phone, email. We're happy to come see you in person, be a little more interactive. The chat's still an option. But I appreciate your time and your feedback. To Mike's point, we really do enjoy providing this service and being partners to the industry. That's that's what it's all about. Not necessarily just selling you more product. We're actually talking about selling you less today. So appreciate you signing in. Reach out if we can help. If not, have a great day.
Okay, thanks,
Thank
guys.
you
Much
all.
appreciated.
Appreciate you all. Yeah, Jason, you can probably stop recording now.